Okay, any questions before I get going?
Are
Yeah.
you going to show us how to use Mercurial?
Actually, yes, we will practice it for the lab. I just got the instructions, but not uploaded yet.
Can you also give us an idea on how to understand this paragraph? Like,
Oh, I see.
with function?
Yes. Okay. Let me see if I'm on the internet. I might have them local too. Hang on. Oh, oof. Nope. Hold it up. Alright, so here's good old Scala doc, and it's kind of like Java doc, but the library is quite different. So the first thing is up here you have this little incremental search field. So let's say you want to know about vector, because we've seen vector a couple of times. And so now you look at vector, and you see that it has a totally incomprehensible list of supertypes. And then when you browse through it, it has an equally incomprehensible list of methods. And that is how Scala is. So the philosophy in Scala is if there is a loop that occurs a few times that is reusable, they tend to turn it into a function. And so as a result, there is a huge number of weird things. I mean, some of them are pretty simple. So if I look here, I see slice. So it takes an interval of elements. I don't know. So it takes something from and to, and that one, when you try it in the REPL, you can try it out, and it does something pretty obvious. Then you'll see some things that are much less obvious, such as sliding. Groups elements in fixed size blocks by passing a sliding window over them. I have no idea what this thing does. I would try it out. And let's just quickly do this. So I'll run Scala. I think a range can be just like a vector. So let me make it like a range. That's easy enough to do. So now let's see. So how do I call sliding? I give it a size and a step. Okay, so res0.sliding of a size and a step. Okay, now I get this iterator thing, and that's a little unhappy because I want to know what it actually looks like. But the easiest way of dealing with that is you call toArray on it. Whenever you get an iterator, just call toArray on it, and then it'll dump the contents of that iterator into an array, and then hopefully that'll be more instructive. Aha! And now what we see here is we have an array of, I don't know how many things, but I can ask it. and have 31 things in here. Okay, so what do I get? I have a vector 1, 2, 3 to 10, then a vector 4 to 13. Oh, what happened is, so it takes 1 to 10, and then it slides it over by 3, so now I get to see 10 to 13, and so on. Now, I don't really know why I would want something like that, but I guess if I have a sequence, well, I want to look at 10 at a time, and then I look at the next batch, and then at the next batch. Then I get the index values in this way, kind of ready-made. So this does not look like a function that you would call more than once essentially, but someone out there will be happy that it exists. Yeah?
What is that square brackets b greater than colon b?
Ah, okay, yes, so that is an excellent question. So over here, you see, sliding. You see, this is a type parameter, and that says that this is a method on vector of A, or vector of B. Let me look. Vector of A. Back to sliding. And now we have this second parameter here, B, that I don't see used anywhere. So I'm at a total loss why it's there.
Subtype, supertype.
So it has a type parameter B that's a supertype of A, but it's always just going to be A. I have no idea. Let me look at an example where I would have an idea. Okay, here I have an idea. Over here we have a sort by function. Sort by takes a function. First of all, it operates on a vector of A. It takes a function whose parameter type is A, and it produces B's, and then the B's have to be ordered, and apparently it sorts it by that. So for example, here's how I might use it. If I have an array of strings, and now I would call sort by, and now I have to give it a function that consumes a string and produces, I make it produce an integer. The length and size. Int doesn't take parameters. What the? Oh, I see what I did. Okay. So, I really wish I could write. Be nice. Plugged in and everything. Okay, we'll have to do it this way. So, this thing here is the type A, because that was the type of the collection. This is the type B, which in this case is int. And when you go into over here, sort by, it needs to infer, it apparently infers this int, and because this B matches the int. So it's there for its type inference. Now, after having gone through this in great detail, the truth of this is I never look at it until I actually need to.
So then how do you figure which functions are available in the library?
Oh, I just look at the thing, and if it looks like it's likely going to do my job, I try it out in the REPL, and if it does the right thing, I move on with my life, and you just use it. Serious.
And what does this implicit mean?
You don't want to know. So that is the problem of ScalaDoc, and I've been bitching about this to the Scala people for a long time, that there ought to be a way of presenting the ScalaDoc in a way that's useful to the application program. So what you see here is all of the decorations that are necessary for the Scala compiler to do the right magic. And it really is a burden. And some of the things are even weirder. And so if you downloaded that little PDF file that I gave you guys the link for, you'll find where I have a rant about that, where it says that some of these things are just unreadable and you just need to learn to glance past them. And so with something like this here, there's got to be some technical reason why this B is there. And I think if I really thought long and hard about it, I could probably figure it out. but another 2 hours of my life would be gone. So I doubt I'm going to actually do it. But so the reason is typically something like that. Otherwise, it doesn't work for integers to raw into conversion or something. I don't know. But don't look at it. Definitely do not try to figure it out just from common sense. Most of the time, by just trying out a couple of things, you can get to the right thing. But yeah, I do feel your pain, absolutely. On the positive side is there have been many times when I needed to do something. Oh yeah, just recently I needed to do something. I needed to put something into an HTML table. And so I needed to deal with rows and columns, and there was something that was just like sliding, but it was called group by, that neatly gave me an array of the first n indexes, of the next n indexes, and so on. And what were previously like 20 lines of messy Java code turned out to be a single line of Scala. So having a lot of these functions available is awfully nice. Okay, so, other questions? Yeah, so really my advice is to just kind of dive in and not be perturbed by the fact that a lot of these things are pretty complicated. The reason that they have all of this can build from and stuff is that the way all of these methods were implemented is they implemented in a single spot in the library, and nevertheless, when you put a method to a vector, it gives you back a vector. If you put a method to an array, it gives you back an array. If you apply it to a list, it gives you back a list, and which is really what the application programmer intends. Well, that's what they want. In the Java library, they achieve that by writing the same code 3 times or 10 times for 10 different collections. And in Scala, they just put it all in one place, but then they need this magic of these implicit conversions that really does make the library kind of hard to read. All right. Yeah.
What's the difference between vector and immutable vector and immutable inclusive?
An immutable vector and
immutable inclusive?
I have no idea what an immutable inclusive.
It's like when you type 1 to 10.
Oh, I see. Well, 1 to 10 happens to give you something called a range. This thing. So it's a range, and I guess it's an inclusive range. A range is a collection that internally is represented by simply the first one and the last one and the increment. So it doesn't internally actually store all of these elements. And a vector, because they might all be different, has to store them all. And so when you take a range, this is actually kind of interesting, and now you apply a method to it. Then notice that what you get back is a vector, because now it no longer is a range. Or actually, this one still might be a range, right? Because okay. But if you square it, now this one cannot possibly be a range anymore, and so it kind of knows that the next best thing it can do is a vector. But if, God forbid, you wanted it as an array, it's there for you to ask. Okay, now you have it as an array. Or if you wanted to have it as an iterator, now you get it as an array. So it's a very flexible collection library.
Can you always use the underscore like how you did in the first?
Yes, and we're going to talk about that today. Yes, because obviously you want to do that. All right, so before getting to the fun part of how you can use that underscore, I'm going to go through the tedious part of closures. So we're going to go in slow motion through the following code here. We're having a function here that takes an integer parameter, and then it returns n times x. Now what is n? N is something that I have previously defined as 3. So what is fun of 2? Well, obviously it is 3 times 2, or 6. No question about it. Now, the remarkable thing here is that n is not defined inside the scope of the function. Right? N is defined on a previous line but you can use it anyway. So the rule in Scala, as in most of these languages, is that if you can lexically see a variable, if it's around in scope, then you can also use it. Anything that you can see, you can use. And it doesn't really seem a big deal because after all, n is immutable. It's 3. It's always going to be 3. And so why not make use of that fact? So let's make this a little bit different. So here I'm defining a function called mul_by. Mul_by now takes n as a parameter. So it's no longer a global variable, it's a parameter. It returns a function. It's okay for a function to return a function. And the function that it returns multiplies with n. So that's a little obtuse. Let's try it out. So I'm making quadruple by calling mul_by of 4. Mul_by eats an integer and returns a function, so quadruple must be a function. What function is it? It is the function that takes anything and multiplies it by 4. So now I'll call quadruple with 5, and that is 4 times 5. So now the weird thing though is if I now call triple by calling mul_by of 3, then triple must have remembered the 3 because it'll multiply everything by 3. But if you look at the code of the function, there's only one n. Well, which n was it? Was it 3 or was it 4? And so what goes on under the hood is that each function, each time that you call this, you get back a function with a different value of n. When you call quadruple, it gives you this piece of code together with the information that, by the way, n is 4. When you call triple, meaning we call mul_by of 3, then you get this function back, the same code, but with a different environment that tells you that now n is 3. So a function in Scala is not just the code of the function, but it is the code plus a little dictionary that tells you what all of the free variables are. A variable is called free if it was not explicitly defined inside the body of the code. So in this code here, x is bound, because it's defined over here, and n is free, because it was not defined inside the function. So this dictionary of these free variables is called an environment, and so a function is really the code of the function plus that environment, plus the binding of all of the free variables. And so whenever you see a function, you kind of have to keep that in the back of your mind, that you kind of think of this function as a piece of code, but it's a little bit more than that. It's the piece of code plus the definitions of the free variables. So when mul_by springs into action, then it returns both of those things. It returns the dictionary, where n is whatever the parameter was, and the code. Such a thing is called a closure, which I probably have here. Yeah. And so the term closure is there for historical reasons, but you'll sometimes read something that Java 8 will have closures, or JavaScript has closures. And all that means is that you have functions that remember the binding of the free variables in there. And it makes for these functions to be more flexible. Here, when this mul_by function would not work any other way. So when you make functions that produce other functions, it is pretty important to have this capability. But it's not usually something one has to think about very much. All right, a bit of a type inference. So we know that Scala is strongly typed. So here I have a variable greeting here, and when I later want to reassign something else to it, then Scala won't let me do this. And it's just like in C++ or Java. Here we have C++. So the variable greeting has a type guarantee. Ever since its declaration, it is always going to hold strings. That's different than in JavaScript. So here we have JavaScript where I define greeting to hold the string hello. And later, if greeting, it can be 42, that's just fine. So in JavaScript, there's no such concept of attaching types to variable. Every variable can at any time during its life hold anything at all. And then, of course, when I finally try to call greeting.length, then I'll get a runtime error. In Scala, if I were to call greeting dot something that you can't do on a string, I would get a compile time error. And so the belief is, of course, that it's always better to get earlier warnings than later warnings. So the strong type is generally beneficial. The only difference between Scala and C++ or Java is that Scala infers types. So when I don't have to say string greeting, I just say var, and then it figures out in the right-hand side there is a string. So obviously this must have been a string. Now this is a very useful feature that many other programming languages are picking up The latest version of C++, for example, has that feature, except in C++ you have to say auto instead of var. Why auto? Because 30, 40 years ago, there was a different meaning for auto that no one remembers, but the keyword still happens to be there. And so they're reusing that. But it's a useful thing. In C# you can nowadays do the same thing. Just Java, it's not quite. Now, you can override the infer type, which once in a while you have to do. For example, here, I might actually want to do this crazy thing that I can put both a string and a number into a variable, and so I can type it as any. In this case, I'm overriding the type inference. I tell the Scala compiler, I know better than you do. This shall be of the type any. The syntax is, first you have the name, and then you have the type, just like with method parameters. With parameter types, unfortunately, you must specify them. So, like here, I have a function like here, like this, and I can't just omit the type. I have to specify what it is. So all parameters are explicitly typed in Scala. That is not true for some other languages. When we look at Haskell, for example, the Haskell compiler will be perfectly able to figure out that x must be an integer, because after all, I'm using it to multiply with another integer, and so it would peek inside. The Scala compiler does not do that. It's simply, it goes kind of top down into the function.
Can you assign any exactly?
Well, if I were, I could try this. I could write, if I wrote any here, what would happen?
Take in.
Huh?
It will take in.
No?
It's incomplete.
It will complain, but what will it complain about? The times, it'll say that any doesn't know how to multiply. Right? Any only has a handful of operations such as toString and hash code, and multiplication obviously is not something that's defined at the level of any. So that's not going to work. You get an error here. So in Scala, the function type is defined. So notice that I did not have to give the return type here. It figured out that if x is an integer and 42 is an integer, the product is an integer, and therefore the return value must be of type integer. The only exception for that is recursive functions. So here I'm trying to define the factorial function, and it's not going to work because the type checker now goes through here. It says, okay, x is an integer, and then it says fact. It says, I have no idea what fact is, and therefore I'm not going to type check this thing. So the remedy is that you have to put a colon int at the end of factorial. Only for recursive functions must you specify the return type. Otherwise, the return type is inferred. But there's another kind of inference that Scala is willing to make, and that's important for us as functional programmers. Namely, it is willing to infer the types of functions that occur as parameters. So look at this function twice that I'm defining. Twice is a function that takes two inputs. Input number 1 is a function, and input number 2 is a value. And so this function here is now applied twice to the value. Not a very useful function, I'm just putting that as an example. So when I call twice with this function here, the multiply by 42 function, then I did not have to put the colon int here. So in the previous lecture, I would have had, I used x colon int. But now it turns out that twice goes through the following devious thought process. It says, well, I know what f is. F is a function that takes an int. And therefore, this thing must also be a function that takes an int. And one doesn't have to write that in this anonymous block. And that's nice because it's less time. So when you call library functions, that's a useful thing to do. Over here, I used it with filter, and it's the same idea. Notice I actually omitted one more thing here. I was sloppy here. Notice the parentheses here. I omitted the parentheses here because there's another rule that says if you have a single parameter, you can omit the parentheses, which I think I have in the next slide. Yeah. So a single parenthesis you can omit, but if you have two parentheses, like with sorting, where two parameters, then you need to put the parentheses. If you omit them, it thinks it's something different. And now finally, for the absolute glory and simplification is, it very often happens that a parameter only occurs once. Over here, the parameter x only occurs once on the right-hand side. And then I can replace it with an underscore, and I don't even have to say x error. If I needed it twice, then I would have to write it. But if I only need it once, I can just replace it like that. And it's a miracle that this works, but once you get over it, it reads pretty nicely. You know, this is the function that tests whether that number is even. Some blob to mod 2 is 0, that tests whether that blob is even. And it even works with 2 parameters, provided each of them is only used once. So, and each of the underscores is a different underscore. If you look very, very closely, you can see that the second one looks a little different. It smiles a little more. And so it checks, yeah, is the first one greater than this? And it's a very compact syntax that people use all the time. So here we're sorting in descending order, right? Normally we would sort by ascending, and now we're flipping the sort order like that. We can do it just with a few keystrokes. So once you get the hang of it, people really like it that they can do powerful stuff by having these very concise ways of writing the functions. Of course, it's also true that some people look at this and then say, oh, my head hurts. So there's 2 kinds of programmers in the world. There's the oh, my head hurts programmers, and they generally do not like Scala at all. And there's the ones who say, oh, this is really cool that I can do so much work with so few keystrokes. And then you'll enjoy it. All right. Now, one thing that's very interesting about function parameters is that you can, once you have a language in which functions are first-class citizens, then you can do away with a lot of control structures. So, for example, good old while. I can implement while in Scala. So I don't actually need while anymore as a built-in of the language. I can write my own while. And here's how I do it. So if you think about what does a while loop do? A while loop has 2 parts. It has the condition that I'm testing, and it has the body. I'm making each of them into a function. So over here, I have the condition. It's a function that has no inputs, and it returns a Boolean. And the body, also no inputs, and it returns something of type unit. Unit is the equivalent of void in other languages. So what does it do? It calls the condition function, and if it returns true, then I execute the body, and then I do it again. That's a while loop. Right? It's recursively written here. Check the condition. If it's true, invoke the body, and keep on going. And so there's no need for having a while that's built into the language, actually. The only thing is, calling it is a little bit ugly. So let's try to call it. So I'm going to call it to print the first 10 integers. So over here, now I'm setting a var to 1. And now here I want to test whether it's less than 10. And notice that the function syntax is just not very pretty. I have to say no inputs arrow, and then the body. And then again for the body, I have to say no inputs, and then a 1, printing and incrementing. And that does look a little bit ugly, and so it might be better to stick with a regular while. Except they've thought of that. That they said they've come up with a mechanism, because this happens so often, they've come up with a mechanism that makes it so that you can get rid of that unsightly no parameter error, because it happens so often. And it's a little obscure how you have to do this. You have to use what's called a by name parameter for historical reasons. And the way you do it is, normally you would put a parameter, you would say, if we look at the previous slide, remember we had a nothing to Boolean, and now over here we omit the nothing part. We're just saying it's to a Boolean. You still need the arrow, because otherwise it would be a Boolean value and not a Boolean function. But we omit the parentheses in the declaration. And now when we do that, then we also don't put parentheses in the call, but it still calls the function. And then when we call the function, we can just supply the code like this. So this looks almost good. So we're saying while, and then the first parameter is the condition as a block, and the second one is the body as a block. So the world would be perfect if we could get rid of these ugly parentheses. Now that's doable by a different trick that actually many languages have, not just Scala. And that trick is called currying, by the inventor of the well-known Indian dish you see on the left. So let's go through the definition of currying. Over here I have a function with two parameters, the mole function. And now actually it turns out that function with two parameters are an expendable luxury. That you can have programming languages in which every function only has a single parameter. And that works by this trick called currying. What you do is you break your function into two, where the first function returns another function. And the way you write it in Scala is like this. So I'm going to define this function mol2. Mol2 takes the first parameter, the x, and then it returns a function that consumes the second parameter. You can always do that with any function, breaking it up into a function that consumes the first parameter and returns the remainder of the computation. So in this case here, mol2 of 3, for example, is a function that already remembers that the first parameter is 3, and then it takes the second parameter and multiplies it with that. So it's the function that multiplies with 3. Now when we apply that currying trick to while, all I've done here is I've said I have a parameter list, and that's for the first function, and then I have a second parameter list for the second function. Otherwise I'm not making any change. Then now this can get very beautiful. I can now say while, and now I put my first parameter, and then I put my second parameter. So it turns out that in this case here, I don't even have to put parentheses around this one. It'll take it with the braces. I could also take braces instead of parentheses here, but that would look kind of weird, so I've left the parentheses. You have the choice whether you use parentheses or whether you use braces. And now I have a perfectly good while operator that works equally well with the regular one. It's just as beautiful, but I've defined it with my own bare hand. So they could kick it out of the language, one less keyword to worry about. Why don't they? There's only one reason, and that's an unfortunate reason. If we look at the definition of while, notice that it's recursive. And on the Java virtual machine, one cannot optimize out this recursion. This is a common recursion pattern called a tail recursion, that on other virtual machines, one could turn the last call into a jump back to the beginning of the function. What's called tail recursion elimination. The Java virtual machine, for no good reasons, doesn't have it. And so that's why they left the built-in while inside. If the Java virtual machine did this kind of common optimization, then Scala would not even have a while. So in other languages, like they will learn later, like in Haskell or in Racket, there is no while. If you want a while, you can program your own while. And it turns out that one doesn't actually need it very often. All right, so in this lab here, what we want to practice a little bit is this whole idea of making your own control structures. So the beauty of having functions as parameters, or one of the many beauties of it, is that you can make your own more powerful control structures. We're so used to the fact that the control structures that we have are what? If, while, for, do. That's all, right? That's the control structures that a regular standard imperative language gives you. That's not actually a lot of control structures. And so if you're in need for another control structure, you can easily build your own in a functional language. Now you might say, why would I ever want to write a control structure? And so I'll give you an example of one that we would want to write. So here's some good old Java code where I'm printing out something to a file. And so how do you print to a file? You make a print writer with that file. You have a bunch of print-ons, and then you have to remember to close the file. Now, of course, you have to close the file in a finally block. Why? No trick questions, plain old Java.
Suppose there is some
Yeah?
error which is not.
Yeah, so say one of these statements here could throw an exception. Can a print-on thing throw an exception? I think it's, as it turns out, print-on is, so I shouldn't have used this example. Print-on actually swallows all of its exceptions. But maybe some of these dots here could throw an exception. It's easy enough for some old exception to happen there. Yeah, so even if there's no space, if I had used an output stream and use written and write, then it would have been able to throw an exception, but print on perhaps not. But if there's some exception in here, then I need to make sure to close the file. Now you might say with a file, big deal, right? But think of you doing something with network connections, where this kind of stuff happens all the time. You make a network connection, and boy, there can always be something wrong with the network connection, right? You might just have temporarily lost the connectivity for whatever reason. And then if you don't close the network connection, what happens? Well, nothing the first time, but after 20 or so times, the database is going to be unwilling to give you more network connections. They're big, hefty objects. So eventually, your program will just stall at a place there where it's far removed from the cause of the original error. These are big pains to debug. And so one wants to religiously always close these resources. And that is a big pain. You have to put the try finally everywhere, and you have to remember to do it. And wouldn't it be nice if there was some way of having having this stuff called automatically? In Java 7, they have rigged the language so that they make a new control structure for this that works for some subset of things. But we can do better in Scala. We can make our own. And so I call it do-write. And do-write takes as a parameter the file that I want to write to. And then that's the only fly in the ointment. And I have to repeat that here as the parameter. Say I want to call it writer. And then here you put the instructions. So this is one that you will be seeing in the lab if we have enough time for it, that you can make this control structure with your own bare hands. And what it is, it's a function that takes as its parameter another function, namely the body of this code. So anytime that you have, in a functional language, anytime that you want to repeat some kind of mechanism multiple times, you can turn it into another function. And that really is the beauty of it. So before that, I want you to do a few practice problems where I'm giving you kind of some common array processing tasks. And I'm asking you to solve these in a functional way. Don't use a loop, don't use recursion, just hit it with some functions. And so I'm giving you a couple hints for these. And so I show you in how many characters of Scala I can solve these, and maybe one of you can beat me with one of these. So I can return an array that has the same elements as the original, any old array, with adjacent elements switched in 41 characters of code. You would need many more times than that in Java. All right, now for this lab, we're going to try the SSH submission, the Mercurial submission, and let's see how it works. So I've made what I hope is a labs project that you should all be able to check out. So do this at the beginning, so if there's problems, then I can troubleshoot them. So what I want you to do is clone that repository. And you should have access rights to it. And if that works, then we're golden. If it doesn't, I'm going to have to fix something. And then later, you can submit the lab report doing that instead of using Piazza, which was not as satisfying. All right, let's get going with that.